Hi, everyone. What answers did you get for the first one? Okay, 494 is close. Any other answers? Okay, Neil, why don't you explain how you got 494?
So it says that there's how many three positive integers have an odd number of even digits. So three digit positive integers are from 100 to 999.
Okay, good.
And so I kind of just so I found out like from 100 to 110, like the amount of the odd number of even digits, how much there were, and there were 6 in 100 to 110.
Okay, which were the six?
They were 100 and 101, 103, 105, 107, 109, 100 and then 110.
Okay. So you didn't count 100, right? 10, starting from 101?
Yeah.
Okay, yeah. And then what did you do after that?
And then I did 111 to 120, and there were 5.
Okay.
And the 5 were 111, 113, 115, and 117, and 119.
Okay.
And then I kind of noticed a pattern because it was 6 for 110 to 111 and 5 for 111 to 120. And then I also did 121 to 130, and there were 6 there.
Okay.
So then I just used the pattern of 5, 6, 5, 6, 5, 6, and found that there were 55 for 100 digits.
Okay.
So then I multiplied that by 8 because 999 was it had one less. So I multiplied it by 8 and got 440. And then I just did from 991 to 999, and then I got one less. I got 5 again, so then I just put 54. And then 440 plus 54 is equal to 494.
Okay. Yeah, you're on the right track. Let's see. So from 100 to 110, this looks right. So let's see, from 111 to 120, let's double check. So it's an odd number of even digits, right? So 111 has 0 even digits, right? 113 has no even digits. So to have an odd number of them, we should have at least 1, right? So that would look like 110 has 1 even digit, 112 has 1 even digit, 114, 116, 118. So this this pattern will work. Like we could do this going forward, but one thing we have to be careful of is that like the number of even digits changes if the first digit is an even or odd number, right? So in this case, when 1 is an odd digit, that would be different from when you're in the 200s, right? Because 200, the 2 becomes an even digit. So it might not actually be exactly symmetric. So let's actually try to think about it a different way. So I think we could do this way, and I think you will kind of get the right value, but you do have to be careful of like the even and odd first digits and even and odd of the other digits. So let's try to think about it in a couple of different ways. But first, okay, if I have an odd number of even digits, what are the possible like digits? I could have like 3 even digits in the 3-digit number. What else is possible?
One even digit,
Good, 1 even digit, and then that would be how many odd digits?
2 odd digits,
Good. Is there anything else that's possible?
2 even digits, 1 odd digit.
So that is possible for
Oh.
a 3-digit number, but it wouldn't have an odd number of even digits, right?
Yeah.
Okay. So these are basically the 2 possibilities, right? And let's start with the first one. How many ways are there to make a number with 3 even digits?
Like using 2, 4, 6, or 8, and just putting like 2, 2, 2, 4, 4, 4, 6, 6, 6, like that.
Good, yeah. So each one, so the first digit, we have 4 choices, right? You can either pick
Yeah.
4, 6, or 8. So there's 4 choices there. What about for the second digit?
Second digit, 0, 2, 4, 6, or 8,
Good. So that's how many choices?
5.
5 choices. And what about the third digit?
5 choices to 0, 2, 4, 6, and 8.
So the total number in this possibility is 4 times 5 times 5, which is
100.
100. Good. Okay, so there's 100 ways of having 100 numbers with 3 even digits. Now let's look at the next one. 1 even digit and 2 odd digits. How many ways are there to do this? So let's actually do an assumption of it's going to be an even followed by an odd followed by an odd. Like we could also have, we know it could be odd, even, odd, or it could be odd, odd, even. So let's take the first case. If it's even, odd, odd, how many choices are there for the first even number?
Five.
Close. So what are the 5 there?
It could be 0. Wait, 0, 2, 4, 6, or 8.
Yes. Although, can we start a 3-digit number with the number 0?
I didn't hear you. It glitched out.
So yeah, 0, 2, 4, 6, or 8 are the even numbers, but can we do the first digit being 0? Is that possible?
No. Oh, wait, no. So there's 4.
Good, 4. Now, what about for the second odd digit?
There's 5.
Good. And the third odd digit?
5.
Good.
And that's 100.
Good. Okay, now let's look at the next one. Odd, even, odd. How many ways for the first odd number? How many choices?
5.
Good. What are the 5?
And then 1, 3, 5, 7, and 9.
Good. What about the second even digit?
5.
Good. And the third odd digit?
5.
Good. What is this product?
125.
Good. And the third one? Number of odds for the first digit?
5.
Good.
5. And 5. It's 125.
Okay, so now let's add them all up.
That's 350.
Okay, so this is total of 350. Now we also have to add the one with 3 even digits.
3 even digits. So that's 100 plus 350, so that's 450.
Good. So the answer, the value should be 450. So you can get it the same way that you were starting with here, but I think when you account for the 200s being different, I think you'll actually get the value of 450.
Oh, yeah.
I think it'll balance out. Like you'll see 11 out of 20 there, and maybe 9 out of 20 in the 200 case when you take 20, and I think it'll balance out.
Yeah.
Okay, any questions on this?
No.
Okay, now we'll go through one more kind of trick for this problem. And kind of to motivate that, how many total 3-digit numbers are there between 100 and 999?
Sorry, I didn't hear.
So how many three-digit numbers are there? We know that all of them are between 100 and 999, right? So how many total three-digit numbers are there?
900.
900, good. Okay, so there's 900 three-digit numbers. Now we know the answer here is 450. What does that tell us about in respect to the total number of three-digit numbers?
Half of the 3-digit positive integers have an odd number of even digits.
Good. So from the answer going back, what we see is that half of three-digit numbers have an odd number of even digits. The other half would thus have an even number of even digits, right? Now, any ideas of a good way of kind of just seeing that initially or kind of convincing yourself of this? So if I take the 900 numbers, right, I can always pair them up. If I take any number, I can do 999 minus the number, right? And like this makes a pair of two numbers. So I know all the 900 numbers, I can pair them up in this way, right? Like 100 would pair with 899. Or let's actually define this a little differently. Let's do, 1099 minus. Okay, so if I have 100, I can pair that with 999. Let's see this. This pairing actually doesn't work. Let me think of this. Maybe 100 and 900. Let's see. Okay, then we can do it in this way. So let's say we have the middle digit. So you have the number 100, right? We can create a mapping of like 0 to 1, 1 to 2, 2 to 3, 4 to 5, 6 to 7, 8 to 9. So if we have the number 100, we can sub out the middle digit between these two pairs. And this would be a 1-to-1 mapping, right? So if I have the number 110, so the number 100, we can map it to 110. The number 120, let's actually do it with the last digit. That might be easier. 101. 2 maps to 103. 104 maps to 105. 106 maps to 107. 108 maps to 109. So basically we can pair up numbers in this way. So we can pair up the number ending with 0 and the number ending with 1. And then pair up a number ending in 2, a number ending in 3, pair up the number ending in 4 and 5, and so on. So let's look at each of these pairs. So in the number 100, how many even digits are there?
2,
Okay, and 101, how many even digits are there?
1.
Okay, so one of them is even and one of them is odd, right?
Yeah.
So one of them matches this criteria, right? An odd number of even digits. So in this pair of numbers, only one can satisfy. Because I know when I switch the last digit from 0 to 1, I must go from an odd number of even digits to an even number of even digits, or vice versa. Does that make sense?
Not really.
Okay.
Like, how does it get to odd number of even digits and even number of even digits when we're looking for an odd number? Even.
Okay, so let's say 100 has an even number of even digits, right? By changing from a 0 to a 1, I'm switching one of the digits from even to odd, right? Because I know when I switch from 0 to 1, one of the digits went from even to odd.
Even to odd, here.
So if initially I had an odd number of even digits, when I make this change, I'll make it an even number of even digits.
Yeah.
Does that make sense?
But isn't 101 an odd number of odd digits? Wait.
It's an odd number of even digits, but initially it was an even number of even digits, right? I'm switching between the two. So basically I'm saying that when I pair the numbers in this way, one of them will have an even number of even digits, and the other will have an odd number of even digits.
Yeah.
Now, I don't know which one is which, because like, for instance, if I had 200 and 201, it would be the opposite, right? So in 200 and 201, 200 has an even number of, has no odd digits, right? So that's actually an even number of odd digits. Sorry.
Yeah.
So we're looking at even digits. It has odd number of even digits. When I switch it to 201, it has an even number of even number of even digits.
Yeah.
Right? So what I'm trying to say is that I can pair up the numbers in a way. So if I take the 900 numbers, I make them into 450 groups of two numbers by just pairing up consecutive numbers. So 100, 101 is a pair. 102, 103 is a pair. 104, 105 is a pair. In each of these pairs, I know that only one of them will meet this criteria, and exactly one of them will meet the criteria, because one of them will have an odd number of even digits. If one of them is odd, the other one will be even. If one of them is even, the other one will be odd.
Yeah. Yeah.
Okay. So basically, I have now 450 groups of each of these consecutive number pairs. One of them will have an odd number of even digits. By subbing the number, the last digit in this way, I know the next one will have an even number of even digits, or vice versa. So half of these, the numbers in, or one number in each pair will satisfy. I have 900 total numbers, so I have 450 pairs. One number in each pair meets the criteria, so thus the answer is also 450.
Yeah.
Does this make sense?
Yeah.
Okay. So there's different ways of making this pair. Initially, I was thinking of kind of grouping 100, 999, but that doesn't actually work. You can think about consecutive numbers. You can think of changing the middle digit in the same way. You can think of changing the first digit in this way. Actually, the first digit doesn't work as well. The middle or the last digits are easier. But there's this idea of a bijection. And it's kind of a one-to-one mapping. So I'm saying that like I can always switch between one element that satisfies and one doesn't. And there's kind of a one-to-one mapping between them. And that idea is kind of what can be useful here. It's a more kind of complicated idea, but I think this is kind of a simpler way of thinking about it, is like I just have 450 groups of two items. One of each of them works, so it must be 450 numbers that satisfy. Any questions on this?
No, thank you.
Let's move to the second one. Okay, good. 300 is right. Neil, can you explain?
It's actually my sister.
Hi, I walked in when you were doing question number 1, so I thought I'd give a shot at question number 2. All I did for this question was, if we know that there's 65% of the question is likes and 35% is dislikes, the difference of that 65 minus 35 is equal to 30. And from the question, we know that 30% is equal to the 90 score that was given. So knowing that 30% of the population of likes is 90, then we can just solve the percentage to what's 100%, and 100% of is equal to 300.
Good. Yeah. So that's correct. And this problem is more straightforward. I think we think about, so if there's 65% of the votes on the video were likes, that means 35% were dislikes. So the difference is 30%. Now we know that the difference, the score is basically the difference, the likes minus the dislikes. If that score is 90, then 30% of the total score is 90, or total number of votes is 90. 30% of something is 90, so we can multiply by 10, divide by 3 for 100%. That gives us 300 as the total number of votes. And then we can go back and confirm if 300 is the total number of votes, 65% is 195, 35% is 105. The difference between the two is 90. That checks out. Any questions on this? Okay, let's move to the last one. Any answers on this? Good. 1 over 80 is right. Nidhi or Neil, can you explain?
Okay, so I pretty much did this like all out. If we know, I just made Aarav, Bhairav, and Chirag all A, B, and C,
Okay.
all A, B, and C, and knowing all the combinations, A is not existent value, and I started with B. So when B is equal to 3, then A is equal to 6 or 9. When B, oh yeah, do you want me to wait for a sec or should
No,
I?
I'll label it this way. It's easier. Yeah. This is
Okay.
C3, 136, 139. Yeah.
When B is equal to 4, then A is equal to 8. And then when B is equal to 5, A is equal to 10.
Okay.
And then moving on to the C's, when C is equal to 1, B is equal to where was it in my work? B is equal to 2.
Okay.
And A is equal to 4, 6, 8, and 10.
Okay.
And then finally, when C is equal to 2, B is equal to 4, and A is equal to 8.
Good.
And out of all that, we can see there's 9 cases, 9 case values here. And doing permutations, 10 times 9 times 8 is the total possibility. So 9 divided by 10 times 9 times 8 is 180.
Good. Yep, that's exactly right. I think this is the best way of kind of approaching this, given that we know that we want Aarav's number to be a multiple of Bhairav's and Bhairav's to be a whole number of a multiple of Chirag's. We do need to do this kind of casework or kind of listing out to see what are the possibilities here. At least when we know that C being larger than 1 makes this much more limited, right? If C is 2, to have a multiple of 2, we need to have then a 4 as B. Multiple of 4 being 8 for A. We can't have a multiple of 3 times any of these. That would go over 10. This is the only possibility with C being 2. With C being 1, B can be 2, and then we have any multiple of 2, 4, 6, 8, 10. C being 1 and B being 3, you have multiples of 3, 6, 9. B being 4, you have the multiple of 4 being 8, 5, multiple of that being 10. So we can see that for each of these, if we tried to go to the next multiple, we would exceed 10. So there are a total of 9 cases here. The total number of possibilities would be, we know particularly here that no 2 of them are getting the same number. So this means that there's 10 choices for what we can assign to Aarav. But once we've assigned that one, there's 9 remaining to give Bhairav, 8 remaining to give Chirag. The total would be 10 times 9 times 8, which would be 720. 9 of the cases work. So 9 over 720 is 1 over 80, which gives us the 1 over 80 answer. Any questions on this?
No, thank you.
Okay, that's it for today's class then. We'll see you all next week.
Bye. Thank
Thank you so
you.
much.
Thank you
Bye.
for